Hello! In this video, we're going to go through learning target 7.2.5 and 7.3.5, which both talk about the interior and exterior angle sum theorems. And so in these learning targets, we're basically going to figure out like what the sum of the angles inside, interior, and outside, exterior of any polygon add up to. And we have different polygons that we're going to look at today. And I'm just going to do a table of the 8 that we're really going to look at. We're basically going to count from 3 up until 10. So remember, a polygon in general is a shape with 3 or more sides. And in some of these examples, you're going to be given a picture, which is helpful, but then in some of them, you're just going to be given a name, and you need to know how many sides that name means. So draw a pretty small table. And we're going to cut it in half. And then we need 4 columns. So half, and then half again. So if we have 3 sides, we know that one is a triangle. If we have 4 sides, we know that one is a quadrilateral. Tri for 3 and quad for 4. If we have 5, that's a pentagon. 6 is a hexagon. 7 actually has 2 names that it goes by. One is a little bit outdated, so sometimes it's still used, but they're trying to switch. So it's either called a heptagon or a septagon. Super similar, just the first letter is different. So heptagon or septagon, they're both 7. 8 is an octagon. 9 is a nonagon. And 10 is a decagon. And so you do have to know all of these in case it asks you, like, what are the angles in a decagon? You have to know that they have 10 sides. I'd highly recommend using flashcards to remember these ones so that you have these memorized. So now before we actually talk about the interior angle sum theorem, which is what we're going to do first, we're going to actually figure it out on our own because there is a formula for it, but if you don't remember the formula or in order to avoid memorizing it, it's pretty easy to figure out with just the picture. So I want you to quickly sketch the shapes with me. So I want you to have a triangle and then a quadrilateral, a pentagon, and a hexagon. And so in order to find the angles on the inside, a triangle is one we already know. We know that a triangle adds up to 180 degrees. And so our n, which is our number of sides, is 3. We have 3 sides. We have one triangle shape, and it's just a triangle, so it's 180. And so our sum of our angles is 180. Now here's the part where it's really cool because you can figure out any number based on the number of triangles you can create within the shape. So you're always going to start like at a starting point. We're going to call that starting point G. And you're going to imagine you draw a line from G to each of the corners. So we can go here, we go here, and we go here. And so this creates two triangles. And so this one is 180, and this one is 180. So it creates two triangles. Our number of sides is 4. The triangles we create is 2. And so since we have two triangles, each one is 180. If we add 180 plus 180, we get 360. Now same thing here, we're going to pick a starting point, G, and we're going to draw a line to each of the corners. So there, 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 and there. And we create 3 triangles, all worth 180 degrees. So we have 5 sides this time, 3 triangles, and our sum, 180 plus 180 plus 180 is 540. And we can keep going, but this is the last one. If we divide this out, we get 4 triangles, 6 sides, 4 triangles, 180 plus 180 plus 180 plus 180 is 720. So to summarize this all up, you can notice that like we have 2 less triangles than the number of sides we have. So 3 sides, I have 1 triangle. 4 sides, I have 2 triangles. 5 sides, I have 3 triangles. So our interior angle sum theorem is just that. The sum of the interior angles in a polygon with n sides is 180 times n minus 2. So we have 2 less triangles than the number of sides. And all triangles are 180. So you can just multiply 180 times 2 less than the number of sides. So if I asked you for the angles in something with 100 sides, you would do 100 minus 2 and then multiply by 180. And so if you forget that, you can kind of like draw this picture and you can see how many triangles you have instead of like memorizing the formula. And so let's do an example where we want to find the interior angle sum of a nonagon. So remember, a nonagon has 9 sides, so n equals 9. And then we can just plug that into our formula. So 180 times 9 minus 2. Well, 9 minus 2 is 7, so 7 times 180 is 1260. And that's it. So that's the interior, so the ones on the inside. The exterior is even easier. The exterior angle sum theorem is that the sum of exterior angles in a polygon is 360 degrees, no matter what. So it doesn't matter how many sides it has, they will always add up to 360. So I want to do a couple examples where they start to use variables, because that's when this is really helpful, is finding out, like being able to actually solve problems using those theorems. So let's say I want you to draw these two pictures and then make sure you pause it if you are running behind so you can draw them yourself. Let's say we have this quadrilateral. And we want to know what the angles inside of here are. So the first thing we need to do is figure out what the total angles are supposed to add up to. So this has 4 sides. So in my formula, I do 180 times 4 minus 2, which is 360. So my total should be 360. So to solve this, I can just do all my angles added up equal 360. And these are all like terms because they're all C's. So 3C plus C is 4, 7, 8C. And then divide by 8. So we get 45. Now in this, we want to know what the angles all are. So some of the angles are just C degrees. So like these two, P and Q, are 45. But these ones are 3C. So I have to multiply this by 3 to get 135. And if you want to double check your work, you know that it's supposed to add up to 360. So you can just do 135 plus 45 plus 135 plus 45. And we get 360. Now let's do one more using the exterior sum theorem. It's pretty much the same, but they extend out all the sides. So let me show you an example. So in this one, we have this picture where you have the exterior angle, so they're on the outside, not the inside. And so if we want to find x, we want to use the exterior angle theorem since they're on the outside. And my exterior angles are always going to add up to 360 no matter what. So I'm just going to do x plus 102 plus 81 plus 63 plus 90 equals 360. We can combine all those together to get 336. And just subtract. To get 24 degrees. And if you wanted to double check, again, you could plug in 24 and do 24 plus 102 plus 81 plus 63 plus 90 should give you 360. So the exterior angles always add up to 360 no matter what. And then interior, you have to subtract 2 from the number of sides and multiply by 180.